sort of thing, that's something that we can help out with. That's exactly what we do. I've been a DBA for over 10 years now, and I stopped counting after 10. I've been an MVP for SQL Server since 2011, and I actually lead a user group here in Orlando called Magic Pass. We call ourselves the happiest user group on earth. We actually meet at the Disney Vacation Club World Headquarters, which is kind of fun. We have a 6-foot-tall Mickey that attends every one of our meetings. He's our #1 fan. So if you ever happen to be in the Orlando area, we meet. It's Celebration around the Disney World area. We meet the 3rd Wednesday of every month. We'd love to have you come and visit our group if you're ever in town and you have the opportunity. And on the bottom here, if you want to catch up with me on social media, I'm on LinkedIn, I'm on Twitter, and I have a blog as well. So with that, let's go ahead and jump into this. Today we're going to talk about disaster recovery versus high availability, 2 very important distinctions that it's important to understand what the difference is between the 2 of them. And then we're going to walk through, the bulk of the meeting, we're going to walk through an overview of all the different technologies. Now, most of the technologies we're going to talk about are things that are included with SQL Server, but some things we'll talk about are a little bit outside of the box, but they're important for us to understand as options when we're considering building out a SQL Server. And finally, we'll talk about planning a strategy, some of the things you need to consider once you understand all the different technologies. Then we'll have some time for Q&A, maybe some time for Q&A if anybody has microphones or if we can get chat working at the end. Feel free, too, if you'd like, to shoot me a tweet. I actually have Twitter up now too, so if you want to ask me a question, you can send me something on Twitter. So let's talk now about disaster recovery and high availability and their differences. Now, I grew up in Florida. I'm a native here, so I'm a little bit of a space nut, hence the images, but I think these describe the difference between the 2 technologies pretty well. On the left, you can see we've got high availability. We've got, on the space shuttle, came with multiple engines. Actually, all rockets nowadays pretty much come with multiple engines. But the idea here is that if you had an engine failure, you could still get into orbit after a certain period in time. And in fact, there was one shuttle mission where they did have one engine fail, but they still made it to orbit. But in any case, you're basically implementing something that gives you the ability to keep on going in the event of some sort of a catastrophic failure. On the other hand, the space shuttle did not have a very good disaster recovery system. Unfortunately, ironically, actually, today being the anniversary of the Columbia accident, they didn't really have a way to escape disaster when something disastrous did happen and caused a catastrophic loss of vehicle. The old days of space travel and even the Soyuz capsules now for the Russian space program still do. And we're actually returning to that now with some of the newer designs because we realize not only do you need to have a highly available system on the back end, but you need some sort of a disaster recovery system on the front end to save your astronauts. And they had this in the Apollo days. This was the escape tower. And they fortunately never had to use it, but the idea here is that if you did have some sort of a catastrophic loss of vehicle, you would have rockets on the escape tower that would jettison, and they would take the capsule off the front end of the vehicle, save your astronauts, and live to see another day. So that's the distinction between the 2. High availability are the things that you do to keep on moving along in the event of some sort of a failure in your system. And if you have a catastrophic failure of your system, the disaster recovery techniques are the things you do to live to see another day. And it's important for us as database administrators, as IT folks, to really understand these 2 differences because we need to be able to clearly explain this to management. If they can't understand it, you're off to a losing battle there. You're never going to be able to put the right kind of a system in place. So we need to make sure that we understand the differences between those 2 so that we can explain it to others. Now, what are some of the things that actually cause us to have to implement disaster recovery and high availability scenarios? There's 2 categories of things that cause these downtime and data loss scenarios. You've got planned and, of course, the more fun things, the unplanned. So planned things are things like maintenance or upgrades, or maybe you're in the financial industry and you'll see large batch updates that take place once a month, and so they really hammer the system on I/O, and you have to you have to sort of reserve the system use for that processing. The unplanned stuff is the really fun stuff. This is the stuff that gets us up at 2 o'clock in the morning. Fire alarms going off, the hardware failures, you might have drive failures. Maybe some of the things you don't quite think about so much, operator errors for the problems between the keyboard and the chair. When you have somebody walk into your office and you say, hey, we keep backups of this stuff, right? Because somebody ran a query and a delete query and forgot to put the where clause on it, and all of a sudden your table is empty. That's always fun. Sometimes there's things that are just completely outside of our control too, like a data center availability. Sometimes stuff happens, right? Look at what happened in Atlanta. I don't think any data centers were lost then, but you can imagine some sort of a catastrophic scenario in a city where your data center might actually live. Might lead to something like loss of power and generators don't have enough fuel to last. Or maybe something more simpler, I've seen this happen before, a backhoe takes out one of the lines running into your data center because they're doing construction outside of the data center. That's always fun. So keep these kinds of things in mind. You need to plan for both. The stuff you know and the stuff that you can't really anticipate but you expect might actually happen. These are some of these considerations that you have to keep in mind when you're talking about disaster recovery and high availability technologies. So let's actually run into an overview of the different technologies. Now, these are things that are things that are out of the box with SQL Server. Things that you get right. When I say out of the box, I mean things you get with the box product. You're going to go and you're going to buy SQL Server. You're going to throw it on a server that you've set up, and you have these options that come baked into the product. With the exception of the first thing we're going to talk about, and it'll make sense in a second, but how we're going to judge all of these technologies that we're going to look at today is we've got a scorecard here. And we're basically going to do a simple traffic light or system or a yes, no, and it wouldn't be a DBA if I didn't say it depends. Several different scenarios. We'll talk about the strategy. We'll look at whether or not it prevents data loss, both from a hardware perspective and from a user error perspective, those oops moments. We'll talk about whether or not it prevents corruption, whether it prevents downtime, whether there's automatic failover, and then look at the costs associated with it. Now, let's see. I see one person here has the feedback of question, and I don't see where there's actually, unfortunately, I don't see where the chat window is. So, oh, that one just went away. Okay, if you do have a question, if the chat is not working in here, by the way, feel free to email me, kendall.vandyke@gmail.com, or hit me up on Twitter as @SQLDBA, or if you have a microphone and you can get in, chime in and ask me a question. Okay, so let's move along and let's talk about the first technology, which is physical redundancy. Now, this is one of those I said was not really built into the product, but it's important to understand. And when we talk about physical redundancy, we're talking about things like RAID, which is redundant array of inexpensive disks. Hopefully nobody's implementing any of their database servers that they expect to be built in with some level of redundancy, and they're using RAID 0, for example. Wouldn't be a good choice. So it's important to understand RAID levels. Other physical redundancy options include things like dual power supplies with your servers. Network card teaming, so you have multiple physical switch paths through your switch fabric to your servers. Hot swappable CPU and RAM is another example. This stuff used to be really expensive, and as the technology has improved, as hardware has gotten cheaper to manufacture, this stuff is basically built into most entry-level servers that you can get these days. I would not recommend implementing any kind of a server, especially a database server, without any set of redundancy in it whatsoever. You're just asking for trouble. Unless you knowingly understand that you've got something else in place to account for that. So as we'll see later, mirroring is one option. Maybe you decide you don't want RAID and you don't want any redundancy in physical boxes because you're going to have multiple physical boxes and another mechanism in place to keep things running. So as long as you understand these things, that's okay. That's the point of the presentation, is so that you can understand these things. But for most scenarios, I would say if you're going to build up a box, you want to make sure you've got these things implemented. So we're going to look at the scorecard for this one. And by the way, this is instance level protection. This is going to, if you put in things like RAID and you have a hard drive failure, that's going to protect your entire instance in one shot. So on our scorecard, we certainly prevent data loss due to a hardware error. We certainly do not prevent any kind of data loss due to a user error. And corruption is usually caused by a hardware problem, so that's definitely out on that column. We certainly prevent downtime, and as far as automatic failover goes, it's a big it depends on here because we don't know if we're talking about switch redundancy with the network card teaming or if we're talking about something else. If you have RAID in place and you lose your switch somewhere and you don't have network teaming in place, you're kind of SOL, right? So that's why it depends. And this is low-cost stuff. Like I said, this stuff is something that comes built into most servers nowadays. There's really no reason if you're going out and buying an enterprise-class server, even entry-level, that you don't get these things with it. Okay, now we're going to transition into everything that's baked into SQL Server. This is all the stuff you get right out of the box product if you stand up a brand new SQL Server. And of course, backups, hopefully everybody knows about. This is bread and butter stuff. Okay, this is something that should be part of any disaster recovery strategy. And I would ask you, if you were in front of me, I'd ask you actually if you were a backup expert, and I would expect everybody to raise their hands. But my next question after that is, are you a restore expert? And I would hope, especially for the DBAs amongst you, that everybody's hands stay raised that yes, you're a restore expert, because it's not enough just to back up your databases. You got to make sure that you actually understand how to restore them and that you test your restores often, because backups are absolutely no good if you can't restore them. I think we all understand basic types of backups. Hope we do all understand basic types of backups. Three basic types, right? You've got full, you've got differential, and you've got transaction log backups. There are some other types of backups in here beyond the scope of this presentation, but there are certainly other options when it comes to backups where you can do individual file groups and other things. But you have to understand the basics. You got to make sure you can do at least a full backup, and if you are in the right recovery model, transaction log backups, which is a good segue to the recovery models. You have simple, which is basically nothing is logged after the transaction is completed. The log is marked for reuse. In the middle of a transaction, things are logged only as long as they need to be for the duration of the transaction, with one exception. If anybody's worked with transactional replication, log records will be retained even in simple mode. So keep note of that for anybody who's actually making use of replication or thinking about that. Your transaction logs can grow if you are using transactional replication and they have not been read yet. We'll actually cover transactional replication here in a minute too. But we've got simple recovery model we just talked about. We've got the bulk logged recovery model and the full recovery model. Full, of course, everything is written to the transaction log in every gory detail, so you could actually restore right back to a second if you have the right chain of backups. In bulk logged recovery model, you cannot restore to a second, but you could actually restore to the tail end of whatever log you've got. So the last record in that transaction log backup that you actually have. And in 2008, we got compression that was built into SQL Server backups. In 2008 R2, it came into standard edition. So that kind of made some of the third-party products that were out there less useful. The vendors have gotten better now about adding in some neat new features, but I think if you're on 2008 R2 or beyond, and you're not using compression, you're not doing yourselves any favors, unless, one caveat there too, if you are using transparent data encryption with your databases, you cannot do compressed backups, but very specific use case scenario there. In any case, I won't spend any more time on this. I think we all get it. Backups, very important. You should do this regardless of what your strategy is. Don't let anybody ever try to tell you that you don't need to take backups because you've got RAID or you've got something else in place. You might even have SAN administrators who will try to convince you that you don't need backups because they're taking SAN snapshots. It's a lie. Don't listen to them. Tell them that you'd rather take care of the backups yourself and have them back up the backups instead, by the way. Any SAN administrator that ever tells you that they've got a good backup strategy for your databases, you're a fool if you're putting your job into their hands. Okay, so don't let that happen to you. This is database level protection. Of course, we can only back up a database at a time. I left the demo slide in there. We don't actually have any demos today because this isn't a lot to cover inside of 1 hour. And if I do the demos, it turns into a half-day presentation. So anyways, backups certainly can prevent data loss due to hardware error if you have a backup from prior to when you had a problem. If you don't, you're SOL, obviously. Same thing with user error. If you have a backup that took place after somebody dropped something, it's not going to do you a whole lot of good. If you've got a backup prior to that, well, you're in good shape. Backups don't necessarily prevent corruption. In fact, you can back up corrupt data. If you have a clustered index that goes corrupt and you back up that database, you've just backed up a corrupt database, and there's not much you can do about it. So the same thing applies with corruption as it does to hardware error and user errors. Backups certainly don't prevent downtime. Chances are if you're restoring a backup because you had some sort of a catastrophic failure, you're down. And so backups certainly don't provide any kind of an automatic failover mechanism. They are low cost, built in. There's absolutely, again, no reason that you should not be doing backups within SQL Server. Okay, database snapshots. This is one that not a lot of people are aware of. And by the way, a really fun drinking game, if you ever want to play it, is get together and see if you can name all the different ways snapshot is used around SQL Server. And whoever comes up last and can't name a way snapshot is used, you got to take a drink. So snapshots used all over the place. It's kind of fun to think of the number of different ways. So with database snapshots, what we've got is a read-only, unchanging view of the database, and it's a kind of a neat way to safeguard against mistakes. What's going on here is you have a source database that you take a snapshot of, and you essentially create a snapshot database off of that source database. And it's an NTFS sparse file. And what that basically means is if you go out to Windows Explorer and you look at that file on disk, what you're going to see is a file that looks like it is as big as the source database, but it actually doesn't take up that many bytes on disk. It can grow to that size, but it's going to actually start off as a really small file, and it only grows as changes start to take place inside of the source database. So as you start making changes, the pages that get changed are copied over from your source database to your snapshot database prior to actually being written to the source database. So this way, this is how you get this unchanging view, this snapshot of the source database. When you select off of the snapshot database, for example, if the page was never changed, the database engine is actually going to go grab the pages from the source database. But if that page has changed, it's going to grab the page from the original or from the snapshot database. And this is kind of nice. It's a nice way if you need to put this in place. For example, if you're doing a rollout and you want to apply some scripts and you want a way to get back to what you applied prior, or what your database looked like prior to applying them without taking a full backup, you could take a snapshot of your database. This is really great for dev environments, for example. I've also used this before where in development environments, the database from production was restored as a different name, but there's SSIS packages that are actually looking for the database as the production name of the database. And so what we did was prior to running the SSIS packages, would create a snapshot database that's named the same as what it's actually looking for, and then the package runs okay and life is good. There's another really interesting use of snapshot databases, which I'll get to in a minute after we cover one of the other technologies. What you do need to understand about snapshots is they are database level protection, and also they are only an Enterprise Edition feature. So if you're not running Enterprise Edition, you're kind of SOL here. And by the way, all of the features that we're talking about today are included in Developer Edition, and that's because Developer Edition is everything. It includes all the features of enterprise. It's just different licensing models. So anything that we talk about here today is part of Developer Edition as well. But in terms of licensed editions that you might be running out in production, the database snapshots are limited to Enterprise Edition. And they'll work with every single recovery model, so you don't have to worry about being in any particular recovery model for this to work with your system. So to our scorecard, do we prevent data loss due to hardware error? No, because you could have an outage and your snapshot is on the instance where your original database is, and that hardware outage will take out both. You cannot create a snapshot on a completely different physical instance or even another instance, whether it's virtual or physical. Your snapshot lives on the same instance as the source database. So if you lose whatever's holding your source, you've lost your snapshot as well. Snapshots can assist you in preventing data loss due to user error. So that scenario I mentioned, like rolling out scripts or doing a deployment, if you take a snapshot prior to your deployment and something goes awry, you can actually restore the snapshot database or select what you want back out of the snapshot database before you drop your snapshot. Corruption certainly is not prevented by snapshots. In fact, if your database hasn't changed and you have a corrupt page that was never changed and never copied into your snapshot database, you're SOL, because it just doesn't exist in the snapshot. Snapshots do not prevent any kind of downtime. You certainly can restore a snapshot or a database from a snapshot, but there's still a process associated with doing that. It's not instantaneous. And there's no automatic failover mechanism in here. And I've put the cost here as a mid-range cost. I think a lot of people these days are running Enterprise Edition, and so it's only mid-range simply because of the licensing cost of Enterprise, but there's no additional hardware requirements really. Disk space, but hey, disk space is cheap, right? I've got more disk space now in my thumbnail than I had, on my 486 with 40 megabyte hard drive growing up. It's just insanely cheap and gets cheaper. So really the only thing that's driving the cost here is the licensing. Let's talk about now transaction log shipping. This was introduced back in, you could roll your own in 2000. Really was formalized in 2005, kind of wrapped with some nice procedures and an interface. And essentially this is a redundant copy or copies of a database or multiple databases. And there's a time-lagged recovery model associated with this. And what's happening here is you can see we have a primary server on the far left in the diagram here, and there's a backup job. And you're going to take a full backup initially and restore it to some other server somewhere else, a secondary server. This is one of the two on the right here. You're going to restore that, and then you're going to take subsequent transaction log backups with this backup job, and they're going to be copied over to a backup share or backed up directly to some backup share. And then you have on your secondary servers, and you can have multiple servers, different data centers if you want, but on each secondary server, there's a copy job that goes and copies all of those backups from the share over to some local location where that secondary can read from them. And then there's a restore job, which on some regular interval will go and actually restore those backups, those transaction log backups that you were taking. And there's an optional monitor server in here that fits in as well. Its job is really just to keep an eye on what's going on. It needs to be able to talk to the primary and secondaries, however many you have. So its job is basically keeping status and history information, so you have one centralized place for reporting. That's all it really does. It doesn't play any other role. If it goes down for whatever reason, it doesn't play any other critical role in making sure that your log shipping continues to function. It's all based around alerting and history. You can imagine that this is database level protection, and because there are backups and there's copying involved and multiple jobs, that's where the time-lagged recovery model comes into place. Typically, you would do something like a 15-minute interval for backing up, and then you'd have your copy job run every 15 minutes, and you'd have your restore job run every 15 minutes, which means somewhere in there, there's a some way the stars would line up that could potentially mean you get as far back as 45 minutes off of your primary server. But in most cases, it's pretty quick. It usually is kept up within 15 to 20 minutes of your server. You can alter that if you want. It's all kept inside of SQL agent jobs, and you can change all those intervals around to whatever you want. I've seen in some cases where we'll do a time-lagged recovery model that will back up during the day off the primary, and we won't actually restore anything during the day, but we'll copy those backups all during the day. And then on the secondary server, we'll actually do the restores at night. And during the day, we'll use that secondary server as a reporting server. So with log shipping, you can set it up so that your secondary servers are readable. And in that scenario that I mentioned with reporting, that meant that we could have, say, a primary server in our data center, and we could have a secondary server that was off-site back at our home office that we used for reporting, so that we could run really massive queries and not tax the production server and not bring a bunch of data across the wire. And with that time-lagged recovery model, we were able to use that reporting server, or guarantee that that reporting server was always as current as 6 a.m. of the current day. And that meant that we could build reports and things like that without having to put any kind of load out on the production servers. It does mean that there's an impact on licensing, though, if you do that. So from an edition standpoint, you need to be on standard edition or up on all of your instances. On your primary instance, if you query it, well, obviously you're going to query it, so you need a license for that. On your secondary instance, if you query it, you need a license. If you don't query it, then, and it's operating only in standby mode, then you don't need a license for it. That's kind of a nice way to get around that. On your monitor server, you need a license for it. So keep that in mind. 2 of the 3 servers are going to require a license, maybe all 3, minimum 3 in that scenario, if you do actually query that server. In fact, anytime in any of these technologies that we're talking about, generally, if you query a server, you need a license for it. If you're going to use it simply for warm standby purposes, you don't need that license. As far as recovery models go, because we're taking transaction log backups, you have to be in either the bulk log or the full recovery model for transaction log shipping to be an option that you can use. Mentioned a couple of caveats here already about the licensing. A few others to be aware of. You cannot back up a secondary server. Once you basically kick off that restore process, it's basically there as a standby only. You can only do a final restore with recovery, and you can actually start using the server, but you can't back it up as a sort of a secondary backup solution. You're kind of stuck there. And of course, your secondary has to be the same edition or higher as your primary server. So you couldn't have a scenario where you got, and version 2, you couldn't have a scenario where you had a 2008 R2 primary and a 2008 secondary. It just wouldn't work, and same with editions. You want to make sure that your secondary is going to be the same edition or higher as your primary. On our scorecard, there's a lot of it depends on this one. On both cases, whether there's hardware error or user error, preventing data loss is really a matter of whether or not you have a secondary that has restored the transaction log that has your data loss. If you're in a time lag recovery model and you're 15 minutes back, and you just discovered that about 2 hours ago you deleted something or dropped the table by accident, you're SOL. In the case of the reporting server that I mentioned, example that I mentioned earlier, then if we drop something today because our server was not restoring backups from today, it was only copying the backups, then we'd actually be in good shape. We could go back and we could get the stuff that we need off that server. From a corruption standpoint, because I guess I could have put an it depends on this one too, but remember I said you take a full backup initially, and then you restore it to your secondary server. Assuming that you don't have corruption at that point in time, everything's good. When you actually have a corruption issue on your primary server, the corrupt data is not what's actually written to the transaction log, it's the transaction itself. I suppose in some scenarios, if you had some wonky data that you ended up writing to the transaction log, it could get propagated through. But if you have a non-clustered index, for example, that goes corrupt, that's not written to the transaction log. The data that gets inserted or updated or deleted is what's actually written to the transaction log. So that transaction gets replayed back on the secondary. It's not a page kind of copy scenario like in the snapshots that we saw before. This is actually replaying those transactions from the transaction log. So this is kind of a nice buffer against potential corruption issues that you may have a problem with corruption on your primary that's not there on your secondary. We don't prevent downtime with log shipping. In fact, if you have to fail over to your warm standby that you're being shipped to, you're probably in a downtime scenario. And there's no automatic failover mechanism with log shipping either. You are basically kind of stuck doing this manually. If you have to fail over, you got to stop all the jobs. You've got to restore your database on your secondary with recovery, and then off you go. And on that note, once you restore a database on your secondary so that you can read from it or do read-write to it rather, there's no way to go back. You can't just suddenly flip it back to start recovering or restoring logs anymore at that point. You could get tricky if you really wanted to with differential backups, but I wouldn't plan that as a strategy. I would basically tell everybody that once you fail over to your secondary, then you're running off that secondary, and you need to have a plan to actually migrate back to your former primary at that point. So keep that in mind. From a cost perspective, yeah, this works with standard edition, but now we're talking about multiple instances, potentially multiple licenses, and so as a result, you're going to need to have spend a little bit more money because you need to have those separate physical instances and the licenses associated with them. So this is a mid-range cost kind of solution as well. This is really tried and true, though. I mean, log shipping's been around for a long time. It's in every version of SQL Server. And actually, there's a lot of great third-party products around here that help you, that sort of wrap SQL Server's log shipping. So this is a really good low-cost solution for disaster recovery. You can imagine a log shipping would be a very useful solution for maintaining an off-site disaster recovery type of scenario. So if you have a secondary data center that you might need to fail over to, you could do log shipping to your secondary data center. You could also even consider doing log shipping to an Azure virtual machine or to a virtual machine running in Amazon EC2. So something else to consider there as well for maintaining an off-site backup or an off-site disaster recovery failover option without having to actually invest the capital in another data center somewhere. Okay. Well, we're going to talk about database mirroring next. Database mirroring came around in 2005, Service Pack 1, and this is basically maintaining a single redundant copy of a database. And there's two modes that you can go into with database mirroring. The technical terms are high safety and high performance. Basically, this is synchronous and asynchronous. So before I explain what those two mean, let's take a look at the diagram. In this scenario, you've got two servers at a minimum, and you have one database called your principal on the primary server, and on your secondary server, you have your database called the mirror. And you have an optional server in here called a witness, and this is sort of like the log shipping monitor server. It plays a little bit more of an important role, though, in that its point is to not only keep an eye on what's going on so that you have a central place for understanding the status of mirroring, but it also plays the role of helping to form quorum. So if server A, for example, drops off the face of the earth because somebody pulled the power cord out and the server shut down, and the witness and server B both agree that they can't talk to server A anymore, then you could have an automatic failover scenario where server B suddenly takes over operations. You need to have a witness server in order to support automatic failover. You don't need to have a witness server in order to do mirroring, though. Now, going back to the high safety versus high performance, or synchronous versus asynchronous. What that effectively means here is that in high safety mode, any transaction that occurs on your principal has to be sent over the wire to your mirror and hardened over at the mirror before it's actually hardened back on your principal and returned back to the client. So that guarantees that you have a bit-for-bit copy of the mirror and the principal that are in sync with one another. Asynchronous, on the other hand, would basically queue those transactions. So the transaction could commit on the principal and be sent over to the mirror, but also returned as committed back to the client from server A before it's actually hardened over on server B. So in a scenario where you want to have synchronous, for example, would be if you have two servers that are in the same data center, right? So let's say you want to have a high availability scenario so that if you have a loss of a server, you can fail over immediately right within the same data center. The asynchronous, on the other hand, might be if you wanted to do something like having a failover in a different data center, where you could certainly have the option, if you wanted to fail over, but you don't necessarily want to incur the penalty of the latency for the wire transfer between the two data centers. For example, I worked with somebody where we put mirroring in place inside the same data center, and that makes perfect sense. When they own their own infrastructure, they own their own equipment, they moved everything from working with their own infrastructure to Amazon, and they moved everything up into the cloud. And in order to maintain the level of redundancy that they still wanted with mirroring, but they also wanted to maintain geographic redundancy, they actually stuck the principal and the mirror in two different geographic regions within Amazon. And so they get kind of the best of both worlds. Should a region go down, and their witness and their mirror see that a region goes down, everything will automatically fail over to their mirror. Now, they did synchronous because of the licensing issues, but I probably, in their case, probably would have done asynchronous, so you didn't have that automatic failover scenario, in terms of short outages. But understand that is an option. You could do different geographic regions and leverage mirroring across those regions. Now, with mirroring, there's a couple of caveats. And by the way, this is database level protection also. I think you kind of got that from the diagram. It works with Standard Edition and Enterprise Edition and up for your principal and your mirror. Your witness can be an Express Edition. This is kind of nice. That means that your witness can be some junky 1U box that's not really that redundant, or is running inside of a virtual machine if you really want to, and it can be running Express Edition. So you can imagine from a licensing standpoint, that's kind of nice because now you're not paying for the license that's associated with that for the witness. But you have to be in the full recovery model. That's one caveat here. You have to be in the full recovery model in order to leverage database mirroring. A couple of other caveats. There are some things that just won't work with database mirroring. So file stream, for example, is one of those. You just can't leverage file stream along with database mirroring. Also, your principal and your mirror need to be the same version and edition of SQL Server. There's a slight asterisk there with that. You can use mirroring to actually do upgrades. So you could do rolling upgrades. So you could actually have your mirror be a newer version, if you want, of SQL Server. And you could fail over to your mirror manually, have it become the new principal, but you won't be able to fail back until you get what was your old principal brought up to date with the right version that matches your mirror, or your new principal in this case. So you can certainly use this to do rolling upgrades. Same applies for service packs, cumulative updates, by the way, for an upgrade scenario. You could go and apply the latest cumulative update or latest service pack to your mirror, fail over so that your mirror becomes your principal, and then go back to your old principal, which is now the mirror, and go apply the service pack there as well, and then fail back. You can't query or back up off your mirror, though, in a mirroring scenario. That's one of the limitations that kind of stinks, frankly, about mirroring, but it's just the way it is. One of the features is you just can't query or back up off your mirror. Now, earlier I mentioned a trick with snapshots, database snapshots. So I fibbed a little bit when I said you can't query your mirror. You sort of can. What you can do if you're running Enterprise Edition is you can actually take a database snapshot of your mirror database, and you could query your snapshot. And that actually works. It's kind of a neat feature. So if you'd like to use your mirror as a reporting server and you're running Enterprise, you could take a snapshot. Just keep an eye on things, because if you have a high rate of change, then obviously your snapshot file is going to grow, and you're going to incur some IO overhead as a result of that, as changes are being applied to your mirror. But being able to snapshot a mirror is kind of a neat workaround to not being able to query a mirror directly. But you do have to query the snapshot database. That's the caveat there. And from a licensing standpoint, the other thing that you need to be aware of with mirroring is that when you fail over, technically you have 30 days to fail back to your principal. So you don't need to license your mirror unless you're on it for more than 30 days. But I would kind of argue there that if you fail over to your mirror and that becomes your principal and you're on it longer than 30 days, you probably have transferred your license over anyways and applied it there. But that's between you and Microsoft licensing. I'm not a licensing expert. Don't hold me to that. But be aware that you do have that licensing caveat. There's a 30-day, technically a 30-day period that you have that you can be running off of your mirror, fail over to your mirror. And if I didn't mention it before, I'll make another mention that in synchronous and high safety, you have support for automatic failover in high availability, or in asynchronous rather, high performance. Then you have to failover manually. You don't have that option for automatic failover. Yeah, I covered that right there with the witness actually. So, and also one other thing about mirroring, you have to fail over your databases one database at a time. And at any given time, this is the other kind of downer thing about this. At any given time, you could have multiple databases that are mirrored between two servers, right? So you could have, let's say you have a SharePoint scenario. This is very common. SharePoint has 5 or 6 databases associated with it. If you implement mirroring with SharePoint, you could have, at any given time, you could have half your databases running on one server as a principal and the other half are on the other server as a principal. You could get into that scenario. SharePoint won't work very well if you're doing that, but there is nothing that groups sets of databases together within database mirroring to ensure that they are always running on the same server as principals at any given time. So be aware of that, that could certainly happen. And monitor it closely if that's a requirement, but you choose to leverage mirroring. We covered licensing. I think the last caveat that I'll mention here too is, and it's not on the slide, but it's worth noting, mirroring has been marked as deprecated in SQL 2012. Now, that doesn't guarantee that it's going away. It just means that it could go away at some point in the future. Typically, being marked as deprecated means you get it for 2 more versions after that, after it's been marked. So with SQL 2014, that's one version. With whatever version of SQL we get after that, 20 whatever, that may be the last. Microsoft could always change that, but just understand that the feature has been marked as deprecated, so it could disappear at some point in the future. I don't know about you, but with 2018, 2020, 2022, wherever we get to with the next version and mirroring finally disappears, hopefully Microsoft has come up with some sort of a replacement. Hopefully they've got always-on availability groups for standard edition. We'll cover that in a second. Or maybe they'll have listened to everybody and recanted and kept mirroring around, or maybe none of us will really care anymore because we'll all be retired and drinking Mai Tais on the beach by that point in time. Who knows? But in any case, be aware of that. It was marked as deprecated. So we'll look at our scorecard now. We do prevent data loss due to hardware error. That's the principle behind mirroring. It is a high availability technology, so absolutely. Unfortunately, we don't prevent data loss due to those whoops moments. Remember, especially if you're in high safety mode. If you drop a table or if you delete data out of a table, it's going to be hardened over on the mirror before it commits back on the principal, and so it's going to drop it in both places and you're SOL. That's why you take backups, right? We certainly do prevent corruption, and I didn't mention this, but this reminds me now. In 2008, some version of 2008 R2 Enterprise or some flavor of it at that point in time, we get automatic page repair. And this is kind of neat. What this means is basically if the mirror has a corrupt page, it can go and detects a corrupt page. It can go and get the page off of the principal and bring it back over to the I'm sorry, if a principal has a corrupt page, I have those backwards. If a principal has a corrupt page, it can go and get it off the mirror. There is actually no mechanism where the mirror has a corrupt page that would get it off the principal. Very important, by the way. So you want to DBCC, if you have the ability to do snapshots, you want to make sure that you do DBCC and check your mirror too regularly, because if you imagine you could get yourself into a really sticky scenario where you fail over from your principal to your mirror and your mirror has a corrupt page, then all of a sudden you failed over and you've got corruption issues that you have to deal with. So be aware of that. But in normal circumstances, your principal can repair a corrupt page by retrieving it off the mirror as well. Sure, we prevent downtime. This is a high availability technology, and that's what high availability technologies do, is prevent downtime. And it depends on the automatic failover is because it depends on if you are in high safety or if you are in high performance. And this is very mid-range cost. It does require multiple pieces of hardware, physical hardware here, or virtual machines if that's what you're running. And it also could potentially require additional licensing, but it is baked in the standard edition. And standard edition is pretty cheap these days, and so you can leverage mirroring at a relatively inexpensive cost associated with it. Okay, let's look at replication, and specifically transactional replication now. There's actually a lot of different flavors of replication. We're going to focus just on transactional replication. I've worked a lot with transactional replication, and there are folks who say it's neither a high availability nor a disaster recovery technology. And in fact, if you look on books online, Microsoft will tell you the same. Don't rely on transactional replication for either of these. But I think it's important to understand what it does in the context of understanding what your options are for high availability and disaster recovery. So we'll spend a little bit of time on this one. This is essentially selective synchronization of objects between instances. And that's the fancy way of saying you can synchronize with transactional replication. You can synchronize tables, you can synchronize views and stored procedures between instances. But it's selective. So unlike the database level protection where it's an all or nothing kind of thing, you can pick and choose which things you actually want to replicate over to your other servers. This will replicate both data and schema changes, by the way. So if you alter a table, for example, you can the alter statement will get replicated downstream as well. And there are options within transactional replication if you would like to replicate the schema for stored procedures, for example, just the DDL for a stored procedure, you can do that as well. And this is close to real time. You can do time lagged on this. This involves SQL agent jobs that are running. We'll show you in the diagram here in a second, but you could actually have transactional replication running continuously, behind the scenes all the time. And there's a couple moving parts and pieces to this, but you can get pretty darn close to real time, such that you make a change on your server where your source of all your data is, and within a minute it'll show up downstream on your replicated servers. So I mentioned there's a couple moving parts and pieces. Here's what's basically going on. You start off with something called publisher on the far left here, and you have your database that is published, and as let's say you've configured a publication here that includes a couple of tables or stored procedures or whatever, and as changes occur, they're written to the transaction log. Now remember I said in transactional replication, it doesn't matter what recovery model you're in, so whether it's simple or not, they're persisted in the transaction log until you have this other process come along here in the middle called the log reader agent. Now, the server in the middle here is called the distributor, and I've represented it logically as a different server for the sake of the diagram. Your publisher and your distributor can be the same server if you want them to be, same instance if you want them to be. In high transaction volume environments, it's recommended that your distributor is actually a different server, but you can imagine that means more licensing issues associated with it and more physical hardware requirements or virtual machines that you have to stand up as a result of that. But a distributor can actually be a distributor for multiple publishers if you want. So in any case, you've got this process called the log reader agent. It's actually an out of server process or an out of executable process. So it's not part of SQL Server itself. It's actually called logread.exe. And its job is to basically go and read stuff out of the transaction log from your publisher and go stick it into a distribution database on your distributor. And that's it. That's its sole job. So once it's read those rows out of the transaction log, it marks them as read, and the transaction log can be reused if you're in the simple recovery model, or reused once it's backed up properly if it's in the full or bulk log recovery model. You've got another agent, another out-of-process executable called the distribution agent that runs distrib.exe. If you want to look in Task Explorer, you can see it. And its job is to read all the stuff that the log reader agent stuck into the distribution database and go deliver that downstream to one or more subscribers. Now, the distribution agent can run either on your distributor, which is called push, because it's pushing the changes downstream to the subscriber, or it can run on the subscriber. That's called pull, because it's actually pulling from the distributor over to the subscriber. In any case, its job is to go and deliver those changes downstream to the subscriber. And then you've got a couple of other SQL agent jobs that run after the fact that go and clean up stuff. So once all of the changes have been delivered to all of the subscribers, they don't need to stick around in the distribution database anymore. So it's the cleanup agent's job to come in and delete those out of the distribution database. Now, this assumes you've got everything with replication set up. There's actually another agent in here, and if you're keeping track, this is number 2. I've mentioned it today. There's a snapshot agent, not to be confused with database snapshots, but there's a snapshot agent whose job is initially to actually go and make a copy of all the stuff that's on the publisher that you've chosen to replicate. So it will use, it'll script out a table, for example. It'll BCP all the contents of the table to files, and then the distribution agent would go in and apply that towards the subscriber as part of initializing a publication. So what happens here is there's nothing, as changes are being delivered to your subscriber, there's nothing that prevents me from going and querying the subscriber. In fact, that's one of the bonuses of transactional replication, is you can use this to actually scale out your reads if you want to. So you could have a central database where you make a bunch of changes to, but let's say you're building a web application and you need to just be able to read a ton of stuff from multiple places, and you don't want to throw all those reads back on your central server where you do all your updates. You could use transactional replication to actually publish those tables out to a bunch of different subscribers, maybe even subscribers in a different data center, and scale out your reads that way. But there's nothing that prevents you from writing to your subscriber with transactional replication. So be careful there, because you might have somebody that could make a change at your subscriber and wonder why it never showed up on your publisher. In plain vanilla transactional replication, there's no mechanism to support that. There are other flavors of replication. There's one called peer-to-peer replication. It's an enterprise feature where you can actually make changes to any of the subscribers in your topology. There was a limited or a feature that was limited to a few versions of SQL Server called updatable subscribers. So you could set up a transactional publication and you could update the subscribers, but that's kind of messy and complex. And then there's another flavor of replication there too called merge replication, but that's really meant for offline devices. So things like setting up a publication where you have several different laptops maybe that get taken out into the field as subscribers, and so they would go offline, you would update a bunch of data in the field, and then you'd come back to your office, plug back in, and those changes would be merged back with your publisher, hence the name merge replication. But for the intents and purposes of transactional replication, vanilla stuff, you can't update your subscribers, but you can certainly tweak your subscribers so that you can optimize them for what their role plays. So if you wanted to scale out your reads, for example, you might have a different indexing strategy on your subscribers than you have back on your publisher. You might have additional indexes that don't exist on your publisher. Kind of a nice way to leverage transactional replication to scale out those reads. This is object level protection at best. And I throw this in here because if you have an article, or if you have an object that is I think it's called an article, that's included in a publication, you actually can't drop that. So if you try to drop a table that's published for transactional replication, you'll get an error message that it can't be dropped. So it's kind of a nice feature, a little bit of protection at best there. And then as far as editions go, you can have your publisher and your distributor need to be standard and enterprise. Your subscriber can actually be Express so long as your replicated objects will fit within the constraints of an Express database, like size-wise. And from a recovery model perspective, you can be in any recovery model that you want, simple, bulk logged, or full. Mentioned a few caveats already. It's selective synchronization. You do have to have a primary key to replicate tables. And really, this is optimal for smaller batch sizes. So if you have some developer who comes in and says, update 500,000 rows in one shot, in one step-based operation, then under the covers, what really happens is you get 500,000 update statements that get inserted into your, that get written to your transaction log, and then get inserted into your distribution database, and then delivered one at a time to your subscriber. So you have to be very careful with this because you want to do small batch sizes of things. Otherwise, you'll have this transaction that's open on your subscriber, and one by one agonizing row of updates end up getting applied there, and you wonder why things are all of a sudden slow on your subscriber. So keep that in mind, that under the covers, the set-based statements are not delivered downstream as set-based statements. They're delivered as row-by-row statements. You can, I mentioned, replicate the execution of a stored procedure. So if you were able to actually wrap your 500,000 row update inside of a stored procedure, and you replicated the stored procedure execution itself, then that would be a single call that would get delivered downstream to your subscriber. It would call the stored procedure execution, in which case you could preserve that set-based update scenario. But for normal updates, if anybody's using ORMs, for example, even if the ORM is optimized to do a set-based operation, if it's doing dynamic SQL and it updates a bunch of rows, it still gets turned into row by row downstream at the subscriber. So be careful with that. From a scorecard perspective, do we prevent data loss due to hardware error? Maybe, because if you have a table that is replicated and you have it on another subscriber, then you've got a copy of that table. You haven't lost any data. You can get it back if you need to in a pinch. But if you have a table that's not replicated and you have some sort of a hardware level error and it wipes out your publisher, you're SOL. Same thing with data loss. If you've got the copy of that table, even more so, not only do you have a copy of the table, but did you deliver the transaction downstream yet? So in a time-lagged recovery model, if you're delivering transactions once an hour, you've got a little bit of a buffer there. If you're doing continuous transactional replication and your changes replicate within a minute, you're probably SOL there as well. So don't count on transactional replication keeping your data protected at the subscribers from boneheaded statements that people might make. Maybe it prevents corruption. It depends on if your article or if your table is replicated. If not, you're SOL. Maybe it prevents downtime. If your application is architected to read from subscribers, you can at least keep on going. If you have a loss back on your publisher, if your publisher goes offline for whatever reason, There's a lot of ifs. I mean, you can look across the row here and just see there's a lot of ifs. There's a lot of it depends here. There's no automatic failover mechanism for transactional replication. I think you can pretty clearly see here, this is why Microsoft and why most of us who are working with these technologies tell you this is not a disaster recovery nor a high availability technology, but I do think it's important to understand. That's why I mentioned it as an option to consider in combination with all these other things. That maybe it's an option that solves a problem that one of these other technologies that we've looked at doesn't quite solve, like scaling out reads, for example. It's a mid-range cost. You can run it with standard edition. Just requires multiple instances, multiple licenses. That's the thing to be aware of. Okay, 2 technologies left. We've got 15 minutes, I think, on the schedule, so we're going to cover these last 2 in that time. Let's start with clustering. I think a lot of us have probably dealt with clustering before. It's been around for a while, since the pre-2000 days, and sometimes it's a cluster. If you've ever dealt with clustering, I think you know what I mean. In clustering, basically what we're talking about is representing an instance, a clustered instance, as one single instance, one single computer, right? It doesn't matter. You could have a cluster that is 3 nodes, 4 nodes, 5 nodes, or 2 nodes, but at any given time, you connect to the clustered instance. You don't care. It just looks like it's one instance running on one computer at any given time. And this is based on top of Windows Server clustering. Excuse me. So you have to make sure you have the right version of SQL Server in addition, right version of Windows, in addition of Windows that will support Windows failover clustering. Now, prior to 2012, that meant prior to Windows 2012, that meant you had to be on an enterprise edition of Windows. So that means cha-ching, there's some coin involved there. If you're running Windows 2012 or higher, that clustering, failover clustering, is actually baked into standard edition. So not a bad option if you're running on Windows Server 2012 or higher. You can spend a little bit less than your licensing costs there. So what does this look like? Basically, this is a simple example. You could have more nodes if you want, but this is a 2-node cluster example. You've got server A, server B. You've got some sort of a shared storage mechanism between the two. It's a SAN or it's a JBOD or something where both of the servers have access to actually get at the disks and control the disk resources. And you've got a virtual network name out front. You connect in terms of SQL Server to the virtual network name, and then you'll have some degree of connectivity between the 2 nodes to ensure that they're up, right? You've got to have some sort of way for the 2 nodes to talk to each other to ensure that they're up and operational. Now, this is a simple example, like I said. You could add multiple nodes in here if you really want to. Now, if you've dealt with clustering in the past, or if you've even vaguely read about clustering before, you may have heard some terms like active-active or active-passive. Throw those out, okay? Get those out of your lexicon because they don't make any sense anymore. Imagine you have a 3-node server and you call it active-passive. Well, what does that mean, right? Is one active and the other ones are just sitting there? Or do you define it as active-active-passive or active-passive-passive? Or how does that work? It doesn't make sense anymore in the clustering world to describe things in terms of active-passive. Basically, what you need to know here is this. At any given time, a node could be in control of one set of disk resources and could be running a database on those resources. So you could have a multi-instance cluster where server A is controlling the one instance and its disk resources, and server B is controlling another instance and its disk resources, but they can't talk back and forth to each other without actually making a connection to the instance names. Okay, there's no mechanism that says that server A can run half the queries for instance 1 and server B can run half the queries for instance 2. That just doesn't make sense anymore. And that's why we throw active-active out the window, because active-active doesn't describe that scenario correctly. So think of it as single instance multi-node or multi-instance multi-node is the better way to describe this. This is instance level protection, obviously, and what you can do depends on your edition. So if you're running standard edition of SQL Server, you can have a two-node cluster. With Enterprise Edition, you can have more than 2 nodes if you want to. And because this is the databases live on shared storage, it doesn't matter what recovery model you use. There's no replaying of transactions that occur anywhere. This is basically a database, and it's a database file, and its transaction logs are written to the shared resource. And at any given time, only one node can control that resource. A couple of caveats. Nodes have to be the same version and edition of SQL. Just like mirroring, though, you can do rolling upgrades. You could take a node that is not in control of an instance at any given time, and you could apply a service pack to it. You could apply a cumulative update to it, or you could even do a version upgrade on it, fail over to that node, and then do the same thing to the node that's no longer controlling any instances. And again, from a licensing standpoint, like most of these other technologies, you do not require, and I use the word passive. I just committed I told you not to do this, and then I used the word, but inactive nodes, let's put it that way. Licenses are not required for inactive nodes. So you don't need to worry about a license for anything that's not actually controlling an instance at any given time. Now, from our scorecard, do we prevent data loss due to hardware error? It's an it depends, because you could lose a node and the other node could kick in, and that's fine. But if you lose your shared storage, like if you're on a SAN, because we all know that SANs are perfect and never have a problem, and something goes down, then it doesn't matter how many nodes you've got, you're down for the count at that point. And because there's no replaying of transactions anywhere, or saving copies of logs or anything else like that, you can certainly have user error issues here, or data loss issues due to user error here. Obviously, since we're on shared storage, there's corruption potential here, so that's out of the picture. It's not something that clustering can help you with. But absolutely, we prevent downtime, and we have automatic failover mechanisms in place when you build out a cluster. This is, however, a very high-cost option because it requires shared storage, which typically SANs are not cheap, and it requires Enterprise Edition if you want to do multiple nodes. So it's costly. Okay. Last one we're going to talk about here is always-on availability groups. And this is sort of like mirroring and clustering combined. You get protection for groups of databases. It is also based on Windows Server failover clustering. And unlike mirroring, you can actually have readable replicas. Now, the terminology's changed a little bit. They're not principal and mirror anymore. They're called replicas. So what's going on here is I've got a scenario. We've got server A is your primary replica, and there's 4 databases that are contained within one always-on availability group. And as you can see, there's synchronous replication taking place over to servers B and C, and there's asynchronous replication taking place over to server D. Now notice there's no witness here. That's not necessary anymore because of how Windows Server failover clustering works. And notice we can mix and match synchronous and asynchronous. The terms high safety and high performance don't apply here anymore either. It's simply synchronous versus asynchronous. All of these are contained within the same Windows Server failover cluster. And unlike mirroring, where you have to know which server is the principal at any given time, you connect instead, sort of like a cluster, you connect to a name of your availability group. You connect to a listener object. If you've worked with Oracle, this is probably familiar to you. You don't connect to server A or server B directly when you want to leverage a database that's in an always-on availability group. You connect to a listener name, and that listener will then redirect your connection to the appropriate server. This is database level protection, and same caveats as mirroring. You got to be on the same version in addition, but you can do rolling upgrades, just like with mirroring and with clustering. You can back up your secondaries. Unlike mirroring, you can back up. You can read from your secondaries. If you read from your secondaries, though, you need a license. And as far as backups are concerned, you can only take a copy-only backup, and you can only take transaction log backups off your secondaries. But at least it alleviates some of the overhead of taking backups. off of your primary server. This is going to be an expensive feature, you can imagine, because this is enterprise only, and this requires the full recovery model. So now not only are we talking about multiple instances, but enterprise and up. So it's going to cost you a little bit more. So on our scorecard, do we prevent data loss due to hardware error? Absolutely. Just like mirroring do. That's the feature that we get out of that. We do not prevent data loss due to user error. Even in asynchronous mode, chances are your transaction is going to be replayed before you can get to it. So if you drop a table, you're probably SOL. That's why we take backups. Do we prevent corruption? Then yes, absolutely. Just like mirroring, you get automatic page repair. So if your principal replica or your primary replica rather has a corrupt page, you can go get it from one of the other replicas. We do prevent downtime. I probably should change this to it depends. As long as you don't have a problem with your Windows Server failover cluster, we prevent downtime. And there's an automatic failover mechanism built into it. So it is a high cost, though, because it's enterprise. Looking over this scorecard, looking over all these technologies, the thing to notice here is as you go up and down each column or across the rows, there's no one technology that does it all. Always on availability groups gets us close, but not quite. And so it's usually a good idea, knowing all of this now, it's usually a good idea to implement a combination of these technologies. That's certainly possible, so that you can protect yourself against as many scenarios as you can afford to protect yourself against. So you can combine, for example, mirroring and clustering with backups. Right. In fact, I'd combine backups with any technology, but you could do mirroring and clustering and backups with replication. So you could actually have your primary server, your publisher, be mirrored and replicate that out to multiple subscribers. You could do log shipping with that as well, or you could do database snapshots with that. Or you could leverage always-on availability groups, and you could take backups off your secondary, and then you could have an off-site asynchronous replica in AWS, right? You want to run an Azure virtual machine, maybe if Amazon's not your flavor, but you could have an async replica off-site for DR purposes, so that you can have an on-site high availability and an off-site DR with always-on availability groups. Let's talk just a minute about strategy planning, and I think we're wrapping up because I'm hitting the scheduled time. Important, now that you understand these technologies, you have to, before you can make any kind of a decision about which one to implement, you need to gather up your requirements. Talk to the business, figure out what needs to be protected, what kind of availability it needs. As DBAs, we tend to think everything needs to be up 24/7, 365, and when you talk to the business, you might discover it only needs to be up from 9 to 5, Monday through Friday, in which case it probably doesn't make sense to go leverage Enterprise Edition and all kinds of other expensive things to keep the database running if it goes down on a Saturday afternoon and nobody cares. Keep in mind things like maintenance windows as well, and performance degradation. With mirroring, you've got a little bit of extra overhead associated with network traffic and with disk latency of applying a transaction in two places. So there are some performance hits that you have to consider. Other considerations: power, space, bandwidth. All of those things come into play because you're adding extra servers into the mix. You have to make sure that you have a place for all these extra servers, and you can afford the cost of maintaining them inside of your data center. Implementation time is another issue. If you've got multi-terabyte database, it's probably going to take you a while to back that up and restore it over to an off-site location, copy it over and restore it to an off-site location to implement log shipping for it. So it's going to take you a while to get that set up. And can you manage it? Would you trust your junior DBA amongst you? If you're a senior DBA, would you trust your junior DBA to know when to fail over or what to do to actually fail over if you needed to? Of course, there's hardware and software limitations with these things. If you can't afford SAN, you probably can't leverage clustering. If you can't afford Enterprise Edition, you can't leverage clustering. Or always on availability groups, right? Money is always a factor. It doesn't grow on trees, right? Finally, when you implement a strategy, or when you're looking into implementing a strategy, test the heck out of it, right? Test it, not just backups, not just restores, but make sure you understand how to actually fail over things. Make sure that it fails over within the amount of time that the business has specified it needs to fail over. Make sure that the applications work properly with failover. Make sure that your strategy meets the requirements that you've gathered before you actually chose or did a proof of concept on your technology. And you have to make sure you can manage it, right? Does your NOC know how to monitor it and know which server is primary? Does your NOC know when to call you when there's a problem, or what those thresholds are for calling you when there's a problem? You have to be able to manage what you've created, obviously, in order for it to be effective. A couple of additional resources, and then we'll wrap up. There's books online, always great bedtime reading. There's a couple of white papers out there that were written for 2008 that are still relevant. High availability with SQL 2008, and the URLs, I'll make sure we get to the group here so that you can go check these out. And then proven SQL Server architectures for high availability and disaster recovery, both white papers that were written by Paul Randall and a couple of other folks who know a little bit about disaster recovery inside of SQL Server. And also the past summit from last year, in 2013, there were a couple of presentations around always on availability groups and high availability and disaster recovery planning, including my half day. If you want to see demos of all this stuff in action, you can go check those out as well. And with that, I think we've hit our scheduled time. I haven't heard any questions from anybody or haven't seen anybody, so if you have follow-up questions, please do contact me. You can email me, again, kendall.vandyke@gmail.com. And we're not quite at the past summit, but thanks for coming this afternoon. You can also hit me up on Twitter, @SQLDBA is my handle. Look me up on LinkedIn, too. It's just Kendall Van Dyke. And I really do appreciate the opportunity to present to you guys this afternoon. And if you have any follow-up, I'm looking forward to hearing from you guys. But otherwise, thank you very much.